What started as a simple idea for a homemade REM pod quickly developed into one of the most ambitious devices we've ever built for VeilGuard. This is the VeilProbe, a custom paranormal investigation device designed to detect disturbances around its antenna, monitor environmental temperature, record time-stamped events, and broadcast live information to a dashboard that we can access from anywhere inside an investigation location. It combines the familiar idea behind a REM pod with a modern networking, data logging, remote monitoring, and software that can adapt to the environment around it. Building it required a lot more than simply attaching an antenna to a microcontroller. Every part of the device had to work together. The sensor, the lights, the buzzer, the internal clock, the temperature probe, the SD card, the Wi-Fi connection, and especially the live dashboard. And as the project developed, the VeilProbe became much more capable than the device I originally set out to build. But before we can get into the construction process, let's talk about what it actually does. If you've watched paranormal investigations before, you've probably seen a REM pod. The basic idea is that the device monitors an electrical field around an antenna. When a person, object, or other conductive material gets close enough to disturb that field, the device responds using lights and sounds. Investigators will often place one in an empty room, near an object, or in an area where activity has been reported. They may then ask questions or invite something to approach the antenna. Of course, a REM pod can't identify what caused the response. It detects a measurable change in the environment surrounding the antenna. That distinction is important. A responsible investigation device should tell us what it measured without automatically claiming to know why it happened. My goal was to take that basic concept and build something designed specifically around the way we investigate with VeilGuard. I wanted it to be portable, rechargeable, easy to deploy, and capable of more than just simply producing a light and a beep. I wanted it to record every response. I wanted accurate timestamps. And most importantly, I wanted the team to be able to monitor it remotely without repeatedly walking into the same room and infecting the environment around it. And that idea became the foundation of the VeilProbe. At the heart of the VeilProbe is an ESP32. The easiest way to describe it is as a tiny computer designed to control electronics. It reads the antenna sensor, controls the lights, buzzer, monitors, temperature, communications with the internal clock, connections to Wi-Fi, runs the dashboard, and records events to the SD card. It acts as a central control system for the entire device. The antenna is connected to a capacitive sensing input. In simple terms, the VeilProbe continuously measures the electrical conditions surrounding the antenna. When something conductive approaches it, those readings change. The software compares the current reading against the normal baseline and calculates the strength of the disturbance. A small change creates a low-level response. A stronger disturbance moves through medium and high, and a major change produces a critical response. Each level has its own light color, audible pattern, allowing us to immediately recognize the strength of a response even in complete darkness. The neopixel ring surrounding the antenna provides the visual indication. Low-level activity appears yellow, medium activity appears orange, high and critical activity appear red. A buzzer provides matching audible alerts, with stronger responses creating more noticeable patterns. The VeilProbe also contains a digital temperature sensor. If the temperature changes significantly from its established baseline, the device records that as a separate event. That does not automatically make the change paranormal. Temperatures can shift because of air conditioning, drafts, open doors, nearby people, or just normal changes inside of a building. The purpose is to capture that information so that we can compare it with our cameras, audio recording, and other investigation equipment later. Every time the VeilProbe starts, it performs an automatic calibration. During this process, it studies the normal electrical environment around the antenna. It measures the average signal, the highest and lowest readings, and the amount of background fluctuation present in the room. That information becomes the device's baseline. This is especially important because capacitive sensing is highly responsive to surrounding environment. Walls, furniture, electrical wiring, power cables, electronics, humidity, nearby metal, even people elsewhere in the room can affect the reading. My office became an excellent stress test because it contains, well, computers, servers, monitors, networking hardware, smart devices, power supplies, and plenty of cabling. It's almost the perfect environment for testing how the VeilProbe handles electrical interference. Instead of using one fixed sensitivity setting everywhere, the software measures the actual background noise present during calibration. It then adjusts its detection thresholds around that environment. In a quiet room, it can remain highly sensitive. In a more electrically active location, it becomes slightly more selective. This allows the same VeilProbe to adapt to different buildings without requiring us to manually rewrite its sensitivity settings every time we move it. One of the most important parts of developing the VeilProbe was balancing the sensitivity with reliability. If a sensor is too sensitive, ordinary electrical noise can produce false responses. Even if it's not sensitive enough, subtle disturbances can be missed. The goal was not simply to make the device react as often as possible, it was more so to make its reactions consistent and meaningful. The software takes several antenna readings at a time rather than relying on a single measurement. It removes the highest and lowest samples, which help eliminate sudden electrical spikes. It then averages the remaining readings to produce cleaner results. Low-level responses must remain consistent across several measurements before the VeilProbe accepts them as a confirmed event. And stronger responses require less confirmation because they're much less likely to be caused by minor background fluctuations. The device also uses hysteresis. That means once an event has been confirmed, the signal must fall clearly below the activation point before the VeilProbe returns to idle. This prevents the lights and buzzer from rapidly flickering between active and inactive states when the signal is sitting close to a threshold. The VeilProbe also tracks slow environmental changes over time. If the surrounding environment gradually shifts, the baseline can gently follow them. But the adjustment is intentionally slow enough that a genuine approach toward the antenna is not immediately absorbed and ignored. This gives the device the ability to remain stable during long investigations while still responding to sudden change. Now this is probably my favorite feature of the entire build. Each VeilProbe hosts its own local web page. Once the device connects to our investigation network, we can open the dashboard from a phone, tablet, computer. The page displays the current temperature, antenna reading, baseline, signal delta, response level, uptime, network status, and the most recent recorded event. It also displays the background noise measured during calibration and the threshold selected for the current environment. This allows us to see not only whether the device responded, but how strongly it responded and what the sensor was reading at that exact moment. From the dashboard, we can synchronize the internal clock, restart the device, begin a new calibration, view recent events, and download the complete SD card log. We can also assign a custom name to each device. That becomes especially useful when multiple VeilProbes are deployed throughout the same building. Instead of trying to remember which network address belongs to which unit, we can just name them based on their location. VeilProbe basement, VeilProbe attic, VeilProbe hallway. You get the idea. The dashboard is accessed through a local address based on the device's name. No internet connection required. Everything operates on our own private investigation network. That means we can enter a building with no usable internet service, create our own local network, and still monitor every VeilProbe for mission control. Adding Wi-Fi introduced an interesting challenge. The ESP32's wireless radio is located on the same board that's measuring very small electrical changes around the antenna. When the dashboard requests frequent updates, the radio becomes more active, and that activity can slightly affect the surrounding electrical environment and occasionally appear as a weak antenna disturbance. Essentially, the VeilProbe in the beginning was sensitive enough to notice parts of its own communication system. Now fortunately, that interference was mostly limited to the weakest low-level signals. The software now accounts for network activity. When the dashboard communicates with the device, the VeilProbe can temporarily filter out weak disturbances that occur immediately around that request. Medium, high, and critical events remain active because those signals are much stronger and less likely to be created by normal Wi-Fi traffic. The dashboard also refreshes at a controlled rate rather than constantly requesting new information. This preserves the live monitoring feature while reducing unnecessary wireless activity. The end result is a system that remains connected and observable without allowing the dashboard itself to become the primary source of responses. The VeilProbe contains a dedicated real-time clock. This keeps track of the actual date and time independently from the main processor. When the device records an event, it can attach an accurate timestamp. That becomes extremely valuable during evidence review. If the VeilProbe responds at a specific time, we can compare that timestamp to our video footage, audio recordings, static cameras, EMF meters, and any other devices operating nearby. The SD card stores that event log locally inside the VeilProbe. Each entry can include the device name, timestamp, antenna reading, baseline, calculated signal strength, response level, temperature information, and operational status. The firmware also creates regular watchdog entries. These are automatic recordings to show the device was still powered on, reading sensors, connected to the network, and communicating with the SD card. If the VeilProbe remains alone in a room for several hours, these watchdog entries give us continuous operational history. During review, we don't have to wonder whether the device froze, restarted, or just stopped recording. The log shows exactly what it was doing throughout the investigation. During an investigation, the VeilProbe should be placed on a stable, preferably non-metallic, surface. We avoid placing it directly beside obvious electrical equipment, power supplies, routers, large metal objects, charging cables, etc. Once it's positioned, we power it on and leave the immediate area around the antenna while it calibrates. The device then enters a self-test sequence. Touching the antenna confirms that the sensing system, lights, and buzzer are working correctly. Once the test passes, the VeilProbe becomes armed and it begins active monitoring. From that point, we can leave the room, observe the device remotely, or allow it to operate independently while the SD card records each event. Because the VeilProbe is battery powered, it does not need to remain connected to a wall outlet or a computer. That makes placement easier and reduces additional cables around the sensor. During extended testing, the device operated for well beyond 16 hours on battery power alone. That provides more than enough runtime for a normal investigation and gives us the option to leave it monitoring an area for long static sessions. There are already plenty of commercial REM pods available. The VeilProbe was built because, honestly, I wanted a device that matched the way our team actually investigates. It's not simply a light and a buzzer attached to an antenna. It's a connected environmental monitoring and logging platform. It calibrates itself for the room, it measures the strength of each disturbance, it monitors the temperature, it creates accurate timestamps, and it records information locally. And it allows us to watch the device remotely without repeatedly entering and disturbing the area being monitored. The VeilProbe can also receive firmware updates through its own webpage. That means improvements can be installed wirelessly without opening the enclosure, disassembling the whole thing again, or connecting the device directly to a computer. I can compile a new firmware version, upload it through the dashboard, and update the VeilProbe from anywhere on the local network. And trust me, that made testing and development significantly faster, and it gives the device room to continue improving over time. Now, it's also important to be clear about what the VeilProbe cannot tell us. It can't identify the cause of a response. It detects a change in the electrical environment around its antenna. That change may be caused by a person, nearby electronics, electrical wiring, environmental conditions, movement around the sensor, or another source. A response by itself is not proof of paranormal activity. And that's why controlled placement, documentation, timestamps, and comparison with other equipment is so important. If the VeilProbe responds to an empty room, at the same moment that an unexplained sound is recorded, a camera captures movement, or another independent sensor changes, then we have multiple pieces of information to examine. The goal is not to label every beep as paranormal. The goal is to create better records of what happened, when it happened, and what other equipment observed at the same time. The VeilProbe developed through several different versions. Early tests proved the antenna concept worked, but transforming that prototype into a stable field device required a lot more refinement. The sensor had to be tuned after being installed inside the enclosure. The baseline system had to adapt without becoming overly aggressive. The Wi-Fi activity needed its own filtering. The dashboard had to remain responsive without constantly affecting the sensor. The SD card, real-time clock, temperature probe, lights, buzzer, and network services all had to operate together reliably. And each round of testing exposed another part of the system that can be improved. And, well, That is a normal part of developing custom equipment. A prototype proves the idea. Field testing turns that idea into a usable tool. What began as a collection of parts on a workbench is now a complete device that can be deployed, monitored, updated, and reviewed as part of a full investigation. The VeilProbe platform still has plenty of room to grow. Additional sensors could also allow the VeilProbe to compare several different environmental measurements at once. Electrical field changes, magnetic field changes, movement, and potentially even human presence detection to help identify contamination from investigators nearby. But for now, this version gives us a capable and expandable platform that can begin collecting real field data. It lights up, it beeps, it logs, it connects to the network, and it gives us an entirely new way to monitor an investigation location. The next step will be taking the VeilProbe out of the workshop and placing it inside a real investigation location. That way, we can evaluate how it performs in older buildings, unfamiliar electrical environments, and the kinds of spaces it was actually designed to monitor. You'll be seeing the VeilProbe in future VeilGuard investigations. As we collect more field data, the software and hardware will continue to evolve. Let us know in the comments what features you would add to the next version, and if you want to see the VeilProbe deployed inside a real haunted location. Subscribe to the channel so you don't miss the upcoming investigation. This has been the making of the VeilProbe, built for VeilGuard, designed for the field, and ready for its first investigation.